Hello everyone, this is a quick video on renewal processes. Specifically, I'm going to try to show the answer to this question. Can an infinite number of renewals happen in a finite amount of time? Now recall that a renewal process, or at least the definition that I'm going to be working with is down here. If a sequence of non-negative random variables x sub 1, x sub 2, all the way through x sub n is independent and identically distributed, that's what IID means, then the counting process, n of t, where t is greater than or equal to 0, is said to be a renewal process. So this is the definition that I'm going to be working with for a renewal process. Now, x of n in this case is the amount of time between 0 events and the first event. So that's what x of 1 means. X of 2 is the amount of time between event 1 and event 2. X sub n is the amount of time between x sub n minus 1 and x sub n. So I'm going to define an extra variable called s sub n. S sub n. And what s sub n is going to be is it is going to be the total amount of time until event n. So this is going to be the sum from I equals 0 to n of all the xi's, where s sub 0 is going to be 0, and s sub 1 is going to equal x1, s sub 2 is going to equal x1 plus x2, and so forth. So again, recall our question is, can an infinite number of renewals happen in a finite amount of time? What we're trying to see is n of t, can this be finite when t is can n of t be infinite when t is finite? So that's the question that we're trying to ask right here. Now, we're going to define n of t equal to the maximum n that we have, where s sub n is less than t, less than or equal to t. So n is the total number of events, which is going to be equal to n of t. S of n is going to be less than or equal to t, where t is the total amount of time that we're considering. So if we're considering a finite amount of time, can our renewals be infinite? And S sub n has to be less than t because that's what makes sense, the amount of time before a specific renewal in that time frame. By the strong law of large numbers, we know that S sub n over n, where n is the maximum, has to equal mu. And this makes sense, right? We take the total amount of time for all events and we divide by the number of events, and we're going to get the average amount of time it takes for an event. Now, the time between of x, which is xi, needs to be greater than 0, so we know that mu is greater than 0. This is something that is known. Another way of thinking about this is looking to see when Sn approaches infinity. So we see if Sn is approaching infinity, then n needs to approach infinity, because if Sn approaches infinity without n approaching infinity, then mu would go to 0, which we can't have. We also know that Sn is less than or equal to t, where t is less than infinity. We know that t is less than infinity because that's a condition that we need to have, and Sn is less than or equal to t by definition. Thus, n of t must be less than infinity. So we have our answer. N of t must be less than infinity. So what we found out about renewal process is if t is less than infinity, then n of t is less than infinity.